Okay, let's continue with this matrices. About this matrices, I want to say one more thing about what's called the echelon matrix. These are will be useful for the, as I said, solving systems of linear equations. That's why we need it here. After the main properties of matrices, echelon matrix. And M cross N, there's a definition. Maybe I should write definition here. And M cross N matrix A is called an echelon matrix. I guess it's called echelon or echelon, whatever. The pronunciation is not important. If the first entry if it is in this form. Like this. So you have first non-zero entry here somewhere, but before this, so in below all these entries, it must be 0. So this is the first non-zero entry of A. And then here you may have anything else. Anything. And then in the second row, the first non-zero entry must be after this, after the second column, or after this first non-zero entry of the first column. And everything below and before and the next columns, it should be 0. And after that, you may have something else. And then in the next row, the first non-zero entry should be after this value, somewhere here. And here, first non-zero entry can be somewhere there, like this. So that's an echelon matrix. And these are called leading entries. So these non-zero entries are called the leading entries. So that's the echelon matrix. And formally, well, I can write the formal definition, but it will take some time. Maybe I should not do it. Okay, so that's the echelon matrix. Is in the first row, the leading entry in a row. A leading entry is the first non-zero entry. Okay, for example, this one. And a matrix is an echelon matrix if as you go down on the rows and the leading entries moves to the right. Okay, so example, for example, 0, 2, 2, 3, 0, 0, 0, 0, 1, 5, for example, 0, 0, 0, 0, 0. This is an echelon matrix, right? In the last row, there is no leading entry because there's no non-zero element. So these are the leading entries. So 2 and 1 are leading entries. Or you may have, of course, like this, 0, 2, 2, 3, 0, 0, 0, 0, 1, 5, 0, 0, 0, 0, let's say -2. This is also now, this is also an echelon matrix, and the leading entries are 2, 1, and -2. So these are the leading entries of the echelon matrix. So the important is that after this 2, all the values before 2 are 0, and the below, and the all the rows before, all the columns before 2 are 0, and in this column everything is 0 except this 2, and etc. And here the first leading entry, second leading entry, and this is the third leading entry, etc. Okay, these are echelon matrices. Examples of echelon matrices. And if each leading entry is 1, and each leading entry, again, entry is the unique non-zero unique non-zero element in its non-zero entry. Oops. In its column, then A is called a row reduced echelon matrix. Again, this is something to do with the systems of linear equations that we will see later. Row reduced echelon matrix. For example, 0, 0, 1, 0, 2, 5, for example, 0, 0, 0, 1, 2, -2, 0, 0, 0, 0, 0, 0, 1, 0, 0. Let me add this one as well. This is a row reduced echelon matrix. The reason is that this. The reason is that here is the leading entries are in the first row. The leading entry is 1. In the second row, the leading entry is 1, and it comes after the first one. And in the last row, the leading entry is 1. And in these columns, this 1 is the only non-zero entry. All the other entries are 0. Okay, this is a row reduced echelon matrix. And for example, if you have one non-zero element, let me change this to something like this. This is almost the same matrix. Except this one. So the leading entries are still 1, 1, 1, but in this row, this one is not the only non-zero entry. So this one might be it can be 1 or 2 pi, it doesn't matter, any number non-zero, so that this is not row reduced. This is not a row reduced matrix. Okay, so later, what we will do about these later, so we will have some operations given a matrix. Matrix A, we can get into row reduced echelon form. We can get it into row reduced echelon form or row reduced echelon form. By the way, if in the last columns everything might be zero, that's also row reduced. For example, if you write everything zero here, not there, sorry, here. This is also a row reduced echelon matrix. Okay, given a matrix, we can get it into the row reduced echelon form by some operations. Which we will discuss the details in the next lecture. What are the operations? For example, let me give a hint. So let's take this example 2, 1, 0, 1, 2, 5, for example. For instance, let's take this matrix. We can, if you interchange first and second row, because of this is 1, because this entry is 1, or you can divide by 2, but let's interchange these two rows. Then it is 1, 2, 5, and 2, 1, 0. The reason is that, which will be clear later, but let me just give you a hint. If you have an equation like this, let's say 2x plus y is equal to 0, and x plus 2y plus 5z is equal to 0. So either you take these first two equations, systems, or x plus 2y plus 5z is equal to 0, this system, and the 2x plus y is equal to 0. So you just interchange the place of these two systems. Their solutions are the same, right? So the equations are the same. So this is roughly, it will correspond to this one. This interchanging the place of two equations. And if you multiply the first row by 2 and then by -2 and add the last here, multiply by -2 and add the second row, it will be 1, 2, 5. You multiply by -2 and add here -3, 0, -10. Okay, now this matrix is in the echelon form. It's not reduced, row reduced. In order to get row reduced echelon matrix, let me continue this way, like this. Let's divide by -3. The second row by -3. It will be 1. And this is 10 over 3. Now the leading coefficients are 1, right? These are the leading coefficients. And now multiply the second entry by -2 and add the first row. Then 1. When you multiply this by -2 and add here, you have 0. -2 and 5, -20 over 3. You multiply by -2 is -5 over 3, right? No, I forgot how to add these numbers. Okay. And 0, 1, 10 over 3. Now this matrix is in the reduced echelon form, row reduced echelon matrix. Leading entries are 1, and everything in these diagonals in these columns are 0 except the leading entries, and we don't care the others. Okay, that will be useful for us, and we will discuss these details in the next week. That's it for today, and I will stop recording now. Recording.